Hi, I'm Stuart Berryhill, and today we're going to teach Lesson 17, Subscripted Variables and Angled Relationships. Let's do this. Starting with 17.1, what is a subscripted variable? Is a question I can hear through the recording. A subscripted variable, previously you've had x plus y equals 40. Those are just variables. Subscripted is where you have number of nickels, for example, and number of dimes. So rather than saying int plus n plus d, nickels and dimes, we're saying number of nickels and dimes. So it's just a little, you just add on to the variable is all you do, but you still solve it the same way. Number of nickels is still one variable, so it has one answer. So it gives us this problem. It says to solve. We have this bracket, so that means that the number of nickels in both equations and number of dimes are going to be the same amount, and we can use substitution or elimination. Either one would work. I'm going to go ahead and use elimination. So I'm going to multiply the top by -5. If you remember in elimination, we have to get one of the top ones opposite with one of the bottom ones. When I multiply by -5, this is going to become -5 number of nickels minus 5 number of dimes equals whatever that is. 5 times 40, whoa, drawing a blank, 5 times 4 is 20, 200, yeah. 200 and then write the bottom. So now we are there, and we can solve. Because these are opposites, they cross out. -5 and 10 is +5. Number of dimes equals -200 plus 250 is 50. Therefore, quick math, number of dimes equals 10. Number of dimes is 10. Plug that in and solve. We can plug it in right here, and that'll be really easy to solve because we would subtract the 10 and get number of nickels equals 30. So here's your answer. It's no different in how you solve it. We just have subscripted variables. That's all those are, and we'll use those soon when we get distance problems. Let's look at some more subscripted variables. This one gives us a lot. It gives us all these. It wrote them horizontally. I like to see them vertically. And it tells us what some of the variables equal. It gives us Rm and Rw. So what I'm going to go ahead and do is I'm going to plug those in to our overall equation here. I'm going to plug this in there and the Rw in right there. So we get 40. I'm going to need a little more space. I'm going to write it down here. 40 Tm plus 60 Tm equals 260. So that's where we're at right now. Oh, not Tm, Tw, sorry. Now we cannot solve yet because we have 2 variables. Can only have one variable to solve. But let's look at this one right here. We got Tm plus Tw equals 5. We haven't really used this yet. How could we use this? Well, what we can do is substitution. So what that means is we're going to isolate either Tm or Tw. Right now the 5 is isolated. We want to isolate Tm or Tw to be able to solve. So say I isolate Tm. That means I would subtract Tw to both sides, and that would be Tm equals 5 minus Tw. So now, because of that, we know the value of Tm and can plug that in here. Draw my arrow. show you where I'm plugging it in. So we can say 40 times 5 minus TW is the value of TM, plus 60 TW equals 260. Now we only have one variable in TW, so we can solve for it. So distribute 40 times 5, that'd be 200. Just 40 times negative TW, 40, or negative 40 TW, plus 60 TW equals a cursive 260. So now that we're here, can add like terms. Negative 40 TW plus 60 TW is 20 TW positive. Now that we're here, we would subtract the 200. Get 60 equals 20 TW. And when you divide by 20, you get TW equals 3. Now let's see, what did we need to find? We needed to, it asked us to find, solve for all of them. Yeah, so we got TW. We already know RM and we already know RW. Let's erase some clutter here. So now the last one we got to solve for is TM, and that's easy because if we go back to this point, TM equals 5 minus TW. Well, then we could say TM equals 5 minus the value of TW is 3. So TM equals 2. And so that's a further example of subscripted variables. One more concept in lesson 17 is angle relationships. This is starting to combine geometry with some Algebra 2 concepts. Now we got this graph here, whatever. The lines are parallel. That's key. When the lines are parallel, we know that there's only two measures of the angles, the small and the large. You remember, we got two parallel lines cut by transversal, got a bunch of small and large angles. So 50 is a small one. We always know that these add up to be 180 degrees. Well, if we tried to say 50 plus 7x minus 2y equals 180, that wouldn't work because that would be two variables of x and y. So we got to use these two. Now, if you look here, right now, if I correlate these figures, this is 50 in this graph. So this is also in the small angle spot. So therefore we know that 5x minus 10y equals 50. They're corresponding angles. So we can say 5x minus 10y equals 50. Now all the other angles, once again, the large angles are supplementary with the small angles. So if this angle is 50, we automatically know that this one is 130, supplementary. So therefore we know 7x minus 2y equals 130. And we the x and y values are the same. So we can put the brackets around it, and we can solve using substitution or elimination. I'm going to choose elimination in this one. What I'm going to do is multiply the bottom. I see a negative 10y and a negative 2y. I'm going to multiply the bottom by a negative 5. The reason I'm multiplying it by a -5 is because I need this to actually be positive to be opposite of the -10y. So let me distribute this and show you. -5 times 7x is negative 35x. Oops. 35x. -5 times -2y is positive 10y. -5 times 130 is negative 650. So we just switched this equation. Now I'm going to bring this down under it. 5x minus 10y equals 50. And now we can solve. We got negative 35x and 5x. That adds to be 30x, negative 30x. These cross out. Negative 30x equals negative 600. And when you divide, you would get 20. Positive 20. So x equals 20. So we found x. Now we got to find y. So we can just plug in any of the x values. I'm going to use this one. 5x minus 10y equals 50. Plug in the x. 5 times 20. 10y equals 50. Make sure you see. 5 times 20, 100. From here, we're getting y by itself. So we got negative 50 equals negative 10y. Divide by negative 10. And y is 5. And if you remember how we write that like so. 20 in the x value, 5 in the y spot. So that'd be your answer, and that's how you do some angle relationships. Just got to use substitution or elimination. You will notice that in Algebra 2, a lot of math problems we do will come back to substitution or elimination. And that is the end of Lesson 17.